For our lesson today, we'll be talking about exponents. This is the first topic in our new expressions unit. So since we're new to exponents, we're actually going to look at what are exponents and how do they fit into all the other operations that we know already, like adding, subtracting, multiplying, dividing. Okay, so if you think about when you learned multiplication, you learned these things called arrays. And when you draw an array, you do the height, 5, and then you do the width, which is also 5. So 1, 2, 3, 4, 5. And then you fill it in so that it's 5 by 5, meaning 5 columns of 5, 5 rows of 5, however you want to look at it. And if you were to count these all up, since it's 5 by 5, it's going to be a total of 25, okay? Whereas over here, this is 4 by 4, and instead of counting these all up, we can just say, well, then that means it's 16, 4 times 4. So when you have something that's the same number times itself, you're going to get one of these special numbers that are called square numbers, like 16 or 25 or 9 or 144, which is 12 times 12. Okay, these are all having to do with exponents. Okay, so exponents have two parts. They have a base and then the actual exponent itself. So what I should say is that anytime you use an exponent, you have a base and it is raised to the exponent. So there are two parts in every exponent-related expression, okay? So the base is the number that's being multiplied by itself. What does that mean? Well, it means that if I say 9 to the second power, 9 is the base. If I say 6 to the fourth power, 6 is the base. Meaning 6 is going to be multiplied by itself. Now we need to know how many times to multiply that 6. And the exponent is the thing that tells us. The exponent is that little number that's written up to the top right. The exponent tells you the number of times that the base is multiplied by itself. So 3 to the 5th, that 5 is the exponent. 2 to the 7th, that 7 is the exponent. So go back a step to that 6 to the 4th. 6 to the 4th means 6 times 6 times 6 times 6. And that is because the base is 6, and the exponent tells us to multiply it by itself, whatever that exponent is equal to. And in this case, it's a 4. So 6 times itself 4 times. It does not mean 6 times 4. Okay? A special case is when you have a exponent of 2 when it is raised to the second power. And we call that being squared. So now you should be thinking squared makes you think of the shape a square. So if you go back up here, these arrays are showing you where that term is coming from. So if I do this out, 5 by 5, that would be a square. This is 4 by 4, it's a square. So when you square a number, it just means you took one number and multiplied it by itself. So 4 times 4 is 4 squared. Over here, 5 times 5 is 5 squared, 5 to the second power. So that's where that term is coming from, and that's what it has to do with these arrays up here. So next up, we're just going to practice looking at these two new words, base and exponent. So when you see a term is just part of an expression. When you see a term with an exponent, the number here is the base, and the number it is raised to is the exponent. So the 3 is the base, the 4 is the exponent. 7 to the third means that 7 is the base, 3 is the exponent. 9 to the second, or 9 squared, 9 is the base with an exponent of 2. 8 to the 9th power means 8 with the 9 as the exponent. And then a weird one, 12 to the 0 power, the base is 12. The exponent is 0. This is actually a cool one because if you do 12 to the 0 power, you actually get 1. And in fact, any number to the 0 power is 1. So I could do 5 to the 0, that's also 1. 8 to the 0, that's also 1. And we'll talk later about why that's the case. All right, so next up, just to make sure we really got it, we're going to complete the terms or the base and the exponent based on the information that we're given. So if I know the base is 5 and the exponent is 3, I'm going to say 5 to the 3rd power. If I know I have 19 to the 2nd power, or 19 squared, that's 19 with an exponent of 2. 11 as my base, 4 as my exponent is going to look like that. Now be very careful if you write it and it looks kind of like this. That looks like 114, which is very different than saying 11 times 11 times 11 times 11, which is what this means. 11 times itself 4 times. Okay? So not the same. Be very careful when you're writing. 16 to the 4th power would be 16 and then 4. 7 as my base, 6 as my exponent, or 4 as my base with 11 as my exponent. So notice here that the exponent can be bigger than the base because all the exponent is doing is counting how many times the base gets multiplied. Now, if this sounds at all familiar to you, you want to think back to when you learned how to multiply. And I'm just going to do a quick little example here. A long time ago in elementary school, you learned how to multiply. And they told you that if you wanted to do something like 5 plus 5 plus 5, that would be the same as 5 times 3, meaning add 5 3 times. And this is a shorter way to write that, a shorter way to remember that answer. Well, in fact, exponents are the next step up from this. So you took adding, turned it into multiplying. When you go up another step, you get exponents or powers. So that's where we are right now. So watch what I can do here. If I change these plus signs and I look at this instead, 5 times 5 times 5, there is in fact a quicker way to write it. It's not 5 times 3, because remember, these had to be plus signs for 5 times 3. Now, it's 5 to the 3rd power. So we actually have a way to quickly write multiplication of the same number multiple times. Okay? So just like when you learned that adding turned into multiplying, like quick adding is multiplying, quick multiplying is exponents. So next up, we're going to talk about expanded form and standard form. You can kind of see that right here. Expanded is when you write all the multiplications out, whereas standard form would be where you actually just say the final simplified answer. Okay, so when you see standard form, that can make you think of the word simplified. Like literally, what does this come out to equal? Okay, whereas exponent form is what we've been talking about, where you see the base with the exponent. Okay, so after you do this table, you will have a better sense of what these terms are, okay? Expanded form shows the full multiplication of the base. So 6 to the 3rd power means 6 times 6 times 6. So remember that little exponent is counting how many times the base gets multiplied. So here, now it's 3 as the base, but 6 of those getting multiplied. That is what the 6th power means. Okay? Now, standard form would be when you simplify the number, when you actually raise it to that power and get the final answer. That is called standard form. Okay? The last one that we're not writing here that we already talked about is when you have it as exponent form, which is what all of these are in. A number raised to a power. That's exponent form. Okay, so expanded form is 5 times 5 times 5. That's 1, 2, 3 5s. So 5 to the third power. If you do that multiplication out, you're going to get 125. Okay, 36. We have to think of how we could make 36. Well, I know that 6 times 6 is the same as 36. So 6 squared, 6 to the second power, 6 multiplying twice, is 36. 7 to the third means 7 times 7 times 7. Remember, this little number up at the top is counting how many times to multiply the base. And we'll do those big multiplications out at the end. 9 to the first power means there's just a 9. There's just one of them, which is just 9. Here we've got 2 times 2 times 2 times 2, which is 2 to the fourth, because there's 4 of them. Okay, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Okay, now 4 to the third. Remember that 3 counts how many 4s we're going to multiply. So 4 times 4 times 4. 4 times 4 is 16, times another 4 makes 64. 3 times 3 times 3 times 3. There are 4 of these 3s, so 3, the base, raised to the 4. Remember, that exponent counts the number of times you multiply. Okay, next up, 27. So if I was going to break 27 down, I know that that's 9 times 3. And I know that 9 is actually 3 times 3, right? So this is actually 3 times 3 times 3. Because 3 times 3 is 9, times another 3 is 27. So 3 to the third power. 2 to the fifth means 2 times 2 times 2 times 2 times 2. 5 times. 4 to the fourth means 4 times 4 times 4 times 4. 4 times coming from that exponent. Okay, 8 to the first, just 8. 8 multiplied once. There's nothing to multiply it by. It's just 8. Okay, now these next two have kind of like combinations. So you're going to do them in pieces. You're basically going to count up how many times each different number got multiplied. So there's 2 2s, which means 2 squared, or 2 to the second power, times 5 multiplied twice, so 5 squared. Same thing with this bottom one. It's 1, 2, 3, 4 of these 3s, so 3 to the fourth, being multiplied by 2 6s that are multiplying, so 6 squared. Okay, and now we're just going to quickly go through and do these multiplications. This is something that would be fine to do quick on a calculator if you needed to. Okay, so 7 times 7 times 7, that's going to be 343. And then we have, down here we missed one, 3 times 3. That's going to be 9 times 3 times 3 again. That's going to be 81, because this is 9 and 9. 9 times 9 is 81. 2 times 2 times 2, 5 times of that. We're going to get 32. 4 to the fourth, that's going to be 256. 8 is just 8. Here we've got the 2 squared and then the 5 squared, so that's going to be 4 times 25, which is 100. And then this bottom one, we've got 3 to the fourth being multiplied by 6 squared. That's going to be a pretty big number. We're going to get 2,916.